So what I like in Paul's online notes is that he places here problems and with answers. So I can check if my solution is correct or not, or my answer is correct or not, because Paul Paul's online notes have answers. Hi everyone. Mm, I am okay. Thank you very much. So today again, we'll go back to the formulas here or properties of integration. This one, the integral of dx is x plus c. Integral of a dx is ax plus c. Then integral of x to the n dx is x to the power of n plus 1 over n plus 1 plus c. And n is not equal to 1. Then we also have trigonometric integrations. And here at the lower portion, we have here integration of terms which have roots or square roots, but the integrals are in arc sine or sine to the negative one, arc sine of x, arc sine of tangent, and so on. So let's check Paul's problem, then we'll solve this one. Yesterday, we had solved the previous section, which is indefinite integrals. This one, so we have solved, I think, 5 or 6 problems here. So today, we'll solve the next section, which is computing indefinite integrals 5.2. Um, we'll start with number 4. I believe we have solved this one yesterday. Yes, yeah, and we'll start today with number 4. So number 4 has an exponent. So I'm using right now whiteboard.com so that I can write on this here. They have a just like a whiteboard where you can write anything. So let's start again with number 4. So right now I'm using my mouse. Okay, right. Then we have here the integral of w to the power of negative 2 plus 10 w raised to the power of negative 5 minus 8 derivative of w. Again, in the rules of integration, those terms in between the integral sign and the derivative of the variable will be integrated. So if in case that the derivative of w is not placed here but here, that means we only need to integrate these two terms. But in this case, the derivative of w is written at the end. So we need to integrate all of these. Now we have to remember the properties that the integral of say for example, w raised to the n, derivative of w is equal to w raised to the n plus 1 over n plus 1, and we have to add a constant, so any constant value. But in other or in higher mathematics subjects, we're going to solve for c, but not today. Also, we have a property that if we have a means any constant value or any number. So the derivative of the integral of a times the derivative of w is equal to a times the derivative of w, or this one is equal to w plus c. So that's it. Now let's go back here to this number 4. So for me, I'd like to process them step by step. So we'll have to um, integrate them separately. So that would be integral of w raised to the power of negative 2 dw plus the integral of 10 times w raised to power of negative 5 dw minus the integral of 8 dw. Then we have here this property. So the power w raised to power n, in this case, our n is negative 2. So that would mean this will become w raised to negative 2 plus 1 divided by negative 2 plus 1. Then plus, again, we can move out 10 here to the other outside based on that's based on this property. Okay, formula. So that would be equal to, so I write this one here in this lower portion. So this is now 10 times w raised to 5 dw will be equal to 10 times the integral of w raised to 5 dw. With that, we'll get 10 times w raised to power of 5 plus 1 over negative 5 plus 1. Then there's 1. So just like here, we're in, for this case, our A is equal to 8. So this will become 8 times W, and you should not forget plus C. Supposedly, all of them will have plus C, and it would just be absorbed to just only C, because C again is any constant value. Then we will be going to simplify. That is W negative 2 plus 1 is negative 1. So same here, negative 1 plus, that's 10. Then times, we have W negative 5 plus 1 is negative 4. Then negative 4 minus 8W plus C. We can simplify this. This will become negative 1 or just negative w raised to power 1. We have here 10. So 10 over negative 4. So finding the common number, the number that can divide both 10 and 4 is 2. So that's 10 divided by 2 is 5. And we have 4 divided by 2 is 2. And we just need to write the sign 5 over 2. Or we can say that is negative 5 over 2. Which means our answer here will become negative 5 over 2 times w raised to power of negative 4 and minus 8w plus c. So we can simplify it further. So this will be our answer. So this is now the integral of this expression. Okay. So the answer to this problem is this one. All right. Now let's check with Paul's answer. So let's click the solution. It only has answer, but it doesn't show us the solution. So we'll just have to change zoom so that 90, and I'll adjust in this one. So let's check. Mm, I'll adjust. Okay, right, that's better. So we have here negative w to the power of 1, correct? We have minus 5 over 2 w raised to power negative 4, correct? And negative 8w plus c, which means we got the correct answer. Hello, thanks. Next. So we'll go back to the problem list and we'll try to solve. So number 5, I think it's very simple. So you have for number 5, that's the integral of 12 dy. So it's just the same with this property. Here, let's use another color. This property. So that's equal to 12 integral of dy, or simply 12y plus c. So if we want to verify if this is correct, so let's check the solution of Paul. So that's 12y plus c. Then we have here some radical signs. So let's check. Let's try to solve number 6. Number 6 is the integral of cube root of w plus 10 times the fifth root of w cube. Multiply them by dw. Again, since these two terms are in between the integral sign and the derivative, then we need to integrate these two. Solve. But before that, we'll have to separate these two. This will become the integral of the cube root of w dw plus the integral of 10 times the fifth root of w raised to power 3, or w cubed, times dw. So let's just copy this first term first, because for the second term, we'll need to move out the constant value 10 outside integral. So that will be 10 times integral of the fifth root of w raised to power 3 dw. Now, the problem here is that we don't have properties for um, that are in this form. You have cube root of something. We only have here denominators. Root the square root of 1 minus x squared. In the upper side, we don't also have those things. So, what do we do here? If we recall, we actually have, I think that's on power rules or exponents. I forgot the title. We have, if you have cube root of w, that is just the same with w raised to power of 1 over 3. That means if there are radical signs, the exponent of our variable is in fraction form. So that means we can rewrite this as the integral of w raised to power of 1 over 3 times dw, or dw, plus, now we have here fifth root of w cubed. So how do we write it? Again, when we have radical sign, that means our exponent is in fraction. So we have fifth root of w cubed will be equal to W raised to 3 over 5. So this is now the form. So this is raised to 3 over 5 dW. Then we can go back to our previous property. And if you check, we can find it here, this one. So that means this will become the integral of W to the power of 1/3 is equal to W raised to power 1 over 3 plus 1. And here we have 1 over 3 plus 1. Then plus 10 times W raised to power of 3 over 5 plus 1 over 3 over 5 plus 1. And we should not forget to write plus C. Now, the next thing is we're going to simplify. But how do we add a fraction and a whole number? So to add a fraction and a whole number, we need to make the whole number become a fraction. Okay? But how do we do that? I don't know. Okay. For it to become a fraction, so we'll just need to, so one shortcut, if I'm going to solve it, I would just make 1 equal to um, a value that has the same number or square or denominator of the other one. For example, if I have 1/3 plus 1, I would just make 1 equal to this value. Then what number will be um, so what number or what should be the numerator if we want to divide it by 3 and the answer is equal to 1? And the answer is equals to 3. So which means um, 3 over 3 is just equal to 1. So we did not change the value, we just changed the form of 1. So that means this will be 1 over 3 plus 3 over 3. Rule of fractions is that we cannot directly add fractions that have different denominators. So we should make their denominators the same. That's why we have what we call finding the greatest common denominator. And here, the common denominator is 3. And we can now combine them. That will be 3. Then that will become 1 plus 3. Another way is that in finding the greatest common denominator, what we will do is we will copy the denominator uh, that has the since this is a whole number, so we'll just copy the denominator of the term that has fractions. That would be 3. And then this will be 1 for 1/3, then plus. And we're going to multiply 3 to our number. So that would be 3 times 1 is 3. So there are other techniques that we can use, but these are the two most common techniques. So this will become W raised to power of 4. Okay, I'll just rewrite them step by step. So this is now 1/3 plus 3 over 3. Then we have 1/3 plus 3 over 3. Then we have plus 10 times W. So this is now over 5. So this will become plus 1 or 5 over 5. Just like what we did in here. Okay? So our denominator will be 3 over 5 plus 5 over 5. Then do not forget to write C. Simplifying further, we will get W 1 plus 3, so that would be 4. Just copy the denominator. Again, we can only add or subtract fractions if they have the same denominator. So all we need to do is copy the denominator and the numerators will be added or subtracted depending on which of or what operator is being used. So here, this will also become 4 over 3. Then plus 10 times, so 3 plus 5 is 8. And copy the denominator. So that's 8 over 5, which means our denominator here is also 8 over 5, then plus C. After which, we're going to change this. If I don't know, if you're familiar with fractions, if say if I have 2 over 4 over 3, that is just the same if we write that as 2 times 3 over 4. Then we can proceed to multiplication. So that would be 2 times 3 over 4. Then we can reduce this since the denominator and the numerator has a common factor, which is 2. And that will become 3 over 2. Because again, that's 2 times 3. And our denominator can be factored out as 2 times 2. Then we can eliminate this one. So this would just be equal to 1. And the result is 3 over 2. So which means this one, for this, that is just equal to W raised to power 4 over 3 times 3 over 4. And we also have here 10. Let me just write the constant values at the beginning. So that's the convention. We will need to write the constant at the beginning of the term. So this will become 3 over 4 times W 4 over 3. Then plus 10 times, you have here 8 over 5 will become 5 over 8 times W 8 over 5, then plus C. Here we have 10 and 5. 10 times 5, then divided by 8. So what shall we do with that? We have 10 times 5, so over 8. Our 10 has factors. We have 2 times 5 times 5. Our 8 has factors 2 times 4 or 2 times 2 times 2. Then we have two common numbers in the numerator and denominator, so we can cancel this out because that would just 2 divided by 2 is equal to 1. So the result would be 3 over 4 times W raised to 4 over 3 plus, so we have what happened? 5 times 5, so that's 25 over 4 W raised to power 8 over 5 plus C. I believe this would be the final answer. However, if you want to write them in radical form, so this will become 3 over 4. So the denominator will become the value of the radical sign. So that's 3 cube root or cube root of W raised to power 4, then plus 25 over 4, then the fifth root of W raised to power 8 plus C. I believe these two answers will do. However, to make sure So we're going to check if we have the same answer with Paul. So here, that's problem number 6. So problem number 6, we have, okay, click the solution, and oh, I have not seen this one. There is a feature here to show us steps. Anyway, all we need to do is check whether our answer is same with the answer of Paul. Okay, what happened? We first need to convert the roots. That's what we have done. Can we hide all steps? Or show problem? Okay, we still need to show problem. Okay, this is it. So that's 3 over 4. So let's check. The answer is 3 over 4. This is correct. The times W to 4 raised to power 4 over 3. And we have plus 25 over 4 times W raised to 8 over 5 plus C. And we got it correctly. So that's it. You have here a what we call instruction from Paul's notes that we have to change the roots into a fractional exponents. All right, now let's go back so that we can find another set of problems. Here, number, I believe we can answer number 7 easier already. You can easily solve number 7. We can easily solve number 7. So let's proceed with a more challenging one, which is for this one. I'm still in doubt if I can solve this. So let's check. I don't know if I can solve this one. So we have number 8 is 4 over x squared plus 2 minus 1 over 8x cubed dx. Let's check whether there are properties that can be used here. If we check this one, we have only this and this one, but this is just limited to 1 over x dx. So only the integral of 1 over x dx is equal to ln of x. But the problem here is that the exponents are not 1. Okay, so I know now we can use the third formula, and that is the integral of x n dx is equal to x of n plus 1 over n plus 1 plus c. So that should be plus c. Take note that the that n should not be equal to 1. Then I can make the exponents of these terms. But anyway, I'll just have to distribute first. So we'll have, or let's just rewrite this first. So let's have, if you have, if we have 1 over x squared, so we can rewrite that as x to the negative 2, which means that if our variable or the value that being raised to power is in the denominator. So if we want to move it to the numerator, so the power will change to negative. And that means we can rewrite this as 4 times x to the negative 2 plus 2 minus 1 over 8 x to the negative 3. We can actually rewrite 1 over 8 as 8 to the negative 1. But since if we will integrate, all we need to do is we move out 1 over 8. So it's not part of, um, we don't need to integrate a constant value. So let's just write it as is. Then proceed now. So this will become integral of 4 x to the negative 2 plus dx. You shouldn't forget dx plus the integral of 2 dx minus the integral of 1 over 8 x cubed dx. Then we will move out the constant value. We have 4 integral of x to the negative 2 dx plus 2 times the integral of dx minus 1 over 8 integral of x to the negative 3 dx. Okay, let's apply this property. This one. So this will become 4 times x to the negative 2 plus 1 over negative 2 plus 1. We have plus 2. Integral of dx is x minus 1 over 8 times x to the negative 4, negative 3, sorry about that, negative 3 plus 1 over negative 3 plus 1 plus c. So we should not forget plus c. This will become 4 times x to the negative 1 over negative 1 plus 2x minus 1 over 8 times x to the negative 2 over negative 2 plus c. So what is 4 over negative 1? So that's just negative 4. So this will become negative 4 x to the negative 1 plus 2x minus. So here we have negative 8 or negative 1 over 8 times negative 1 over 2. So negative times negative is positive. 1 over 8 times 1 half is 1 over 16. So this will become plus 1 over 16 x raised to negative 2 plus c. I think we can stop here. However, if you like to write it in positive exponents, so this will become negative 4 times 1 over x plus 2x plus 1 over 16 times 1 over x squared plus c, which is equal to negative 4 over x plus 2x plus 1 over 16 x squared plus c. Now let's check with Paul's answer. So that this is number 8. So the answer of Paul should be either these two. Let's check number 8. Please open, please open. Start solution and show step 2. So we are correct that we change the exponent to the negative 4 So what happened is this. I'm sorry, there's actually a solution here, but in the previous examples, what I can remember is that it only shows answer, but I guess these are difficult, more difficult problems, so that's why he showed all the steps. Okay, let's go back. Let's check. So we have -4. So Paul is writing his answer in this form. -4, x to the -1, 2x, 1 over 16 times x to the -2, and plus c. Yay, we got it correctly. And let's go back to another set of problems. All right, let's have number 9 is the same form. So we'll go to number 10. So what shall we do if the given is this, number 10? So that is the integral of t squared minus 1 times the quantity of 4 plus 3t derivative of t. And I think we also don't have a property or formula that can answer that will have a direct integral to this. The best way is to multiply these two binomials. So that would be t squared minus 1 times 4 plus 3t. We'll start with here, so that would be 3t times -1, so that's negative 3t. 3t times t squared, so that is 3t cubed, because that is t squared times 3t. So since they have the same variable and the procedure operation is multiplication, so that's just equal to t squared plus 1, or 3t cubed. Then after, let's multiply this with 4. So this is a constant value, so we'll just write 4 here. Since we don't have the same variable and exponent, so that would be 4. And the other one is 4t squared. So I can write here, probably here, 4t squared. So that if I'm going to add them, we cannot add them since they have different exponents of the variable t. So we'll just have to write them down. That's 3t cubed plus 4t squared. So I'm sorting, or I'm arranging them from the highest exponent to the lowest exponent. So that would be 3t minus 4, which means the expanded form of these the product of two binomials is 3t cubed plus 4t squared minus 3t minus 4 dt. So again, those in between the integral sign and dt should be integrated. So this will become the integral of 3t cubed dt plus the integral of 4t squared dt minus the integral of 3t dt minus the integral of 4. Let me just erase these. Sorry. Hmm. I'll just write it in a very, very cute letter. So that's dt. All right. Then move out the constant value. So that's 3t cubed dt plus 4 times the integral of t squared dt minus 3 times the integral of t dt minus the integral, or 4 rather, times the integral of dt. Then let's follow the rules, formula. So that is 3 times t cubed plus 1 over 3 plus 1 plus 4 times t squared plus 1 over 2 plus 1 minus 3 times t to the 1 plus 1. Again, it is understood that if a value or a variable has no exponent, uh, it actually has exponent, and that is 1. So that's why it's 1 plus 1. Then minus 4t. The derivative of dt is t. And we should not forget c. If it's indefinite integral, we're actually solving right now indefinite integrals. So we must always place c. And go simplify further. So this will become t to the fourth over 4 plus 4 times t cubed over 3 minus 3 times t squared over 2 minus 4t plus c, or that is equal to 3 over 4 times t to the fourth plus 4 um, 4 over 3 times t cubed minus 3 over 2 times t squared minus 4t plus c. So let's check if our answer is correct, or if we have the same answer with Paul. This is number 10, right? So Paul's answer is, oh no, what happened? Maybe I multiplied. So let's check the given t squared minus 1, 4 plus t. All right. I'm sorry about that. It's not yet the answer. So we have here, this one is this. Okay. So here is now the final answer. I thought I was wrong. So that is 3 over 4 t to the fourth, 4 over 3 t cubed minus 3 over 2 t squared minus 4t plus c. And we got it correctly. So let's go back to the next problem, which will be solved. I think we'll solve number 3. So let's try number 3. Number 13 rather. Number 13, right? And that is the integral of x to the fourth minus the cube root of x over, I think that is 6 times square root of x, then dx. So what shall we do with these? We don't have, again, properties or formulas for this, so we need to simplify first. So let's try to rewrite them in this form. You have x to the fourth over 6 plus 1. 6 times square root of x minus cube root of x over 6 times x. Then we have the x. Afterwards, we'll rewrite their exponents into fraction form. So that will be x to the fourth over 6 times square root is 1/2. Then we have minus x times 1 over 3 over 6x to the power of 1/2, then dx. Next is, again, if you recall that for a while. So if you recall that um, if we have 1 over x to the power of 1/2, that is just equivalent to, we say, x to the power of negative 1/2. So what will happen is that this will become integral of x to the fourth. So we'll just move out 1 over 6 here. And we'll have x to the fourth times x to the power of negative 1/2. So if we want to change a fraction into in this form, so that this will happen. Then we have minus 1 over 6 x to the 1 over 3 times x to the 1/2 dx. After this, we can combine by rule of multiplication. If you recall, if this is addition, we cannot add variables that have different exponents. However, if it's multiplication or division, then we can do that. So how to do that? We're just going to add their exponents. Say, for example, we have x squared times x cubed. All we need to do is add their exponents. So that will be 2 plus 3, or that is x to the power of 5. Okay, so what will happen to this? So we'll have 1 over 6. This will become x to the power of 4. Since this is negative sign, so this will be minus, not plus. Then minus 1 over 6, x to the power of 1/3 minus 1/2 dx. Next, we'll combine. So again, finding the least common denominator, not the greatest, but the least. So I'm sorry for the earlier statement. So this will become, I have to make the denominator of 4 equals to 2. So that means if I have 4 minus 1/2, so to make the denominator of 4, remember that if I want to, uh, earlier that we make 1, 1 will be just equal to 2 over 2. So we have 1 is just equal to 2 over 2. The purposes of this, so that they will have the same denominator and we can add their numerators. So this will be 4 times 2 over 2 minus 1/2, or that's 4 times 2, 8 over 2 minus 1/2. So that, or simply that's all over 2, then multiply 2 by 4, so that's 8 minus 1. We have minus 1 over 6 And what will happen here for this case, or in this case, we have 1/3 minus 1/2. They don't have the same denominators. But if we will multiply 3 by 2, so if we will multiply 1/3 by 2 over 2 and 1/2 by 3 over 3, remember the 3 over 3 is just equal to 1. So that means we did not change any value. We did not change the value of 1/3 because 2 over 2 is just 1/2. No, what we need to do is to change their form without changing their values. So that will become 1 times 2 is 2, 3 times 2 is 6. Then we have 1 times 3 is 3, 2 times 3 is 6. Now, they now have the same denominators. And that's the time that we can add them. So this will become 6, 2 minus 3 dx. Next, 1 over 6 x. So 8 minus 1 is 7 over 2 minus 1 over 6. That's 6. I wrote 16. So that's 6. 6 x. 2 minus 3 is negative 1 over 6 dx. Then we can now proceed to integration. So that it has a long way before we can integrate. So this will become 1 over 6 times the integral of x to the 7 over 2 minus 1 over, don't forget the dx. 2 dx minus 1 over 6 times integral of x to the power of negative 1 over 6 dx. So 1 over 6, this is 7 over 2. So that's x, the power of 7 over 2 plus 1 over 7 over 2 plus 1 minus 1 over 6 times x, the power of negative 6 plus 1 over negative 1 over 6 plus 1 plus c. And this will become 1 over 6 times 7 over 2 plus 1. So that's x 7 over 2 so that's plus 2 over 2. So that's the least common denominator minus 1 over 6 times, that's x to the negative 1 over 6 plus 6. So this is negative 1 plus 6 over 6 plus c. Then we have 1 over 6 times, that's x to the power of 9 over 2 over 9 over 2 minus 1 over 6 times x to the power of 5 over 6, because negative 1 plus 6 is 5. That's 5 over 6 plus c. After, so this will become 1 over 6 times 2 over 9 times x to the power of 9 over 2 minus 1 over 6 times 6 over 5 times x raised to power of 5 over 6 plus c. Here, we can divide this by 2. We can divide this by 2. The result is 3. So the result is 1 over 27 x to the power of 9 over 2 minus, we can cancel out 6. That's 1 over 5 times x to the power of 5 over 6 plus c. And this is now our final answer. But before rejoicing, we need to check first in the solution of Paul. All right. So let's check if this is correct here. So this portion. So this one. But let's go down to the last step. So that's 1 over 27 times x to the power of 9, correct? Minus 1 over 5 times x to the power of 5 over 6. And plus. Yeah, we got it right. Okay. So this is now our practice. Now we'll try to solve one for trigonometric problems. And we will continue this tomorrow. Okay, I'm still on my study mode, my review mode. And let's try to answer number 14. So let's have number 14. Number 14 is the integral of sine of x. Others would just write it as sine x. Sometimes it's written with parentheses, sometimes it's not. It depends on the book. Then we have plus 10 cosecant squared of x dx. Since these are now in trigonometric forms, so we're going to check our formula. Here we have integral of sine. All right, we have integral of sine. We have cosecant. We also have integral of cosecant. Therefore, we can solve this problem. Okay, so let's just rewrite it first. That's sine of x. So if you take note, there are no parentheses here. Again, it depends on the book or on the author. So you have sine of x dx plus integral of 10 cosecant squared of x dx. So not yet. So let's have sine of x dx because we need to move out first 10. That's 10 times the integral of cosecant squared x dx. Then, what is the integral of sine? So that is negative cosine of x plus 10. Then the integral of cosecant is negative cotangent. So that would be negative cotangent cotangent of x. And do not forget c. Simplifying further, this will become negative cosine of x. That's 10 times negative, so that's minus 10 cotangent of x plus c. Okay, this is it. So let's check. We have number 14. So show solution. We have negative cosine rather, and negative 10 cotangent of x. And we got it correct. All right. And for this night, I'm tired already solving a lot of problems. So far we have solved 4, 5, 6, 7. 7 problems for tonight. And I'll need to answer more in the next meeting. Okay, I hope you will be with me in the next video. Thank you. Thank you very much for watching. See you in the next video.